I'm Anil Kumar sharing with you a test problem on factoring quadratic expressions. The question here is factor 20 times x to the power of 4 minus 125x squared plus 180. I'd like you to pause the video, answer the question, and then look into my suggestions. Now, when you look into this trinomial, it has degree of 4. However, we have terms with x squared and x to the power of 4. If you substitute, let us say, x squared as some other variable, let us say n, and in that case, x to the power of 4 can be written as n squared. If you do this substitution, you can actually write this expression as a quadratic expression. Let us see how. We have 20 x to the power of 4 minus 125x squared plus 180. So it could be written as equal to 20 x to the power of 4 as n squared minus 125 x squared as n plus 180. Now it becomes a quadratic expression which you can actually factor using the techniques learned. As you can see, we have these three coefficients, constant 180 and the coefficients 20 and 125. There 5 is a common factor. So first we can group factor 5. So if I do that, I get 20 divided by 5 as 4n squared minus 125 divided by 5. You can also use calculator, right? So 5 goes 2 times, 25 5 times. And then for 18, 5 goes 3 times, 15, and 30 is 6 times. So we could write this as 5 times something in bracket. So we have factored. However, it is not completely factored. We can further factor it. Now, this is not a perfect square. 2n whole square, 6 square, but the center term is not twice 2n and 6. So that means it's not a perfect square. But we can still factor it using product and sum. So that means we are looking for two numbers whose product should be, so we are looking for, let's say, p and q, whose product should be 4 times 36, and when you add them up, that is p plus q, we are looking for minus 25. Now what are these two numbers? So that is what you need to figure out. So let's work out. So what you can do is, you can actually multiply these, get the product, but what I prefer is, we'll write their factors, 4 times 36, right? So it could be written as, let me write 36, and then factors of 36 could be, for example, 9 times 4 is 36, and 4 could be further factored as 2 and 2, right? So likewise, we can factor them into different terms, correct? Now, we are looking for combination so that when you multiply these numbers, you get product of 4 and 36, and of course all factors when multiplied will give you that. But more than that, when you add them up, you get minus 25. Now what combination can give you that? So now 4 times 4 is 16, and 16 plus 9 is indeed 25, right? So we do have a combination here. So what we can do is, we can combine these terms, 16 and 9. So if I consider 16 times 9, both with negative sign, then on multiplication we get the positive product, and when we add, we get minus 25, right? So those are our numbers which could help us to factor. So let's continue with those numbers. So we have 4n squared. So that means instead of minus 25, I'll write minus 16n minus 9n plus 36, correct? Now we can combine the first two terms and the last two terms and further factor. So we get 4n common. We are left with n minus 4, and in this case we have 3 common, 9 common. So we could take minus 9. We again get n minus 4. Now n minus 4 is common, so we could write this as n minus 4 times 4n minus 9. So that is how we can actually factor them. But what is n? N is x squared for us. So let us write x square for n, and then we'll further factor. So we have here x square minus 4 times 4x square minus 9. Do you see that? Now what we get here is a difference of square. These two are difference of squares. So we could actually further factor these also. Then what do we get? X square minus 4 is x square minus 2 square. I could write this as x plus 2 times x minus 2. How about the second factor? 4x square minus 9. That could be written as 2x whole square minus 3 square. So I could factor this as 2x plus 3 times 2x minus 3. Do you see that? So that is how we can actually factor the given trinomial fully. Do you understand? Let me show you this once again. 4x square minus 9, you can treat this as 2x whole square minus 3 square, correct? And therefore, we could factor this as 2x plus 3 times 2x minus 3, as we did here. Do you see that? And that is difference of squares, which could be factored as x plus 2 times x minus 2. This is a very important question from test point of view. I have seen it so many times in the test paper. Have a good look at it, practice doing it, and try to find similar questions from your book. Thank you and all the best.